Math 100, section 6.2 involves factoring trinomials. And in our trinomial, our a value is going to be 1. So here's what a trinomial will look like. Ax squared plus bx plus c. So the a value being 1 we're talking about is this a right here, the coefficient of x squared. And so for lesson 6.2, that coefficient is going to be a 1 when we get ready to factor the trinomial. So I'm going to show you 2 ways to factor trinomials. Different people say it different ways, and you're welcome to do it a different way. If you've had a teacher in the past that taught you to factor and you really like the way they said it, fine. Just make sure you show your work and show how you're doing it. I want to make sure that it works for all problems and not just sometimes. So the things that I'm going to show you are going to work for all problems, not just sometimes. All right, so the 2 methods that we are going to use is we're going to use grouping, which is the thing we learned in section 6.1, or we're going to do this thing that I like to call faux fractions. Now, a faux fraction is a fake, okay? It's not really a fraction. It's a faux fraction, okay? So some people really have a problem with that just because it's not really a fraction. But no matter which way that we do this, both ways start exactly the same. We are looking for 2 numbers such that when I multiply them, I get the product of a times c in our trinomial. Those same 2 numbers, when I add them, I want to get b. So here's how that translates for this particular problem that we're doing. We're looking for 2 numbers that multiply to be, our AC would be 1 times 6. Okay, so we're looking for 2 numbers that multiply to be 6. Yes, I really just wrote 7 down. 2 numbers that multiply to be 6. We're looking for 2 numbers that when I add them, I get the b value. And in my particular problem, my b value is 5. Okay, so 2 numbers that multiply to be 6, but when you add them, you get 5. So the numbers you fill in these blanks have to be the exact same numbers. So notice I put 2 times 3, that does give me 6. 2 plus 3, that does give me 5. So I have successfully found my numbers. Now from here is where you choose to do grouping or faux fractions. Okay, when you are grouping, here's what we're going to do. Our first term is going to come down. Okay, this x squared, it just comes down. Our middle term, the 5x, we replace that with the 2 values we just found, that 2 and 3, but we put the x with them because 2x plus 3x, notice that is 5x. And then we take our 6 and it comes down. All right, and so from section 1, now we have 4 terms and we would group. All right, we would group. So if I group these 2 and then group those 2, I factor out what they have in common. My second group would have a 3. Now my 2 groups both have an x plus 2. And when I factor that out, it gets multiplied by what is left, which would be x plus 3. All right? Now, faux fractions, here's what we would do. We take our a value and we put it over one factor we just found. Okay, we put it over one number we found. Then we take a and we put it over the other number we found. Okay, so here's what that would look like. Now, when we take a, we put the x with it. All right, so our a value in this particular problem is 1. So we have a 1x over one of the numbers we found was 2. The other number we found was 3. And so here's why it's called a faux fraction, because now I read it top to bottom. And so I read this as 1x plus 2. 1x plus 3. Notice that these factors are exactly the same as the factors that we did by grouping. So the solution to this problem is x plus 2 times x plus 3. That is the factored answer. Now, you can choose to do this grouping or faux fractions. Some teachers just teach guess and check. Some people show a box method. In fact, I think my math lab might show you a box method. But whichever of those that you prefer is fine. Just make sure you show it and make sure it works, that you're not just making up stuff. All right, so I've got 3 of them that I'd like us to practice. So this will be the second one that we've done. And again, you get to choose which method. I'm going to do both on this one, just so you can see them both happen again. No matter which method you choose, we're starting with 2 numbers that multiply to be a times c. My a value is 1, my b value is -6, and my c value is 8. That's good to know. A times c is 8. 2 numbers that add to be the b value. You do have to take the sign with it, so you have to call it -6. Right, I know 2 times 4 is 8, but 2 plus 4 is not -6. So I can't just say 2 and 4. That would not work. But -2 times -4 does give me +8, and when I add -2 and -4, I do get -6. So I have found my numbers. So if I choose to do this by grouping, you don't have to do it both ways. I'm just going to show you both ways. So grouping, my first term comes down. My middle term gets replaced by the numbers I just found, including the x. And then my last term comes down, the +8. Now I factor by grouping. The first group has an x in common. Factor it out and I'll be left with x minus 2. The second group, if this has a negative right here, you must take the negative out. So we're going to factor out -4, and I'd be left with x plus 2. All right? Let's think that through. Hopefully you'll notice that is not correct. Let me show you. Let me show you. Teachable moment here. If I distribute this back through, that would give me -4x. If I distribute this through, that would give me -8. Okay, notice this is not a negative. So this is a mistake that I expect some of you to make. Okay, be careful. This should have been x minus 2. Okay, now when I distribute it, I would get +8. Okay. So now I've got my 2 groups, and my 2 groups both have an x minus 2. I factor it out, and I multiply by what is left, which would be x minus 4. All right, so there's my factor by grouping. Now I told you you could do the other way, faux fractions. So if you choose to do faux fractions, my a value is 1. It gets an x with it. It goes over one of my values. My a value with x goes over my other value. And so now I read it, and so this would be x minus 2. And this would be x minus 4. Notice either way, I got x minus 2 times x minus 4. Now a common question that people ask me all the time is, on my paper, I put the x minus 4 first and then the x minus 2. That's fine. Okay, that's okay. Either of those would be fine. All right, I'm going to do one more of these and then we'll move on to a different kind of question. All right, so we're still factoring here. Now, anytime my directions say factor, I always do what I did in section 1, look for a greatest common factor. There's not one. Are there 4 terms? Nope, there's not. So since this is a trinomial, that's what I do. 2 things multiply to be a times c. My a value is 1, my b is -6, and my c is -27. So a times c is -27. Two numbers that add to be the b value. All right, so two numbers that multiply to be negative 27. All right, I know 9 times 3 is 27, and now I have to get my signs correct. Okay, because that won't give me negative 27, and when I add it, it won't give me negative 6. But if I do this and I put a negative in front of that 9, now it would give me negative 27 when I multiply. It will give me negative 6 when I add. All right, again, you get to choose either way, grouping or faux fractions. Okay, again, I'll do it both ways just so you can see it happen. For grouping, my first term comes down. I rewrite the middle using my terms that I found. My last term comes down. Now I group, I'm sorry, my y's turned into x's all of a sudden. Okay, now I group. So I have a y times y minus 9. And this group has a 3 in common. Y minus 9. All right, so now my two groups have a y minus 9 in common. I factor it out, and it would be multiplied by what's left, which would be y plus 3. So y minus 9 times y plus 3. All right, let's do the faux fraction way. We take 1x and we put it over one of the numbers we found. We take 1x and we put it over the other number we found. Now we read it like this. Now, if at any point your faux fraction could simplify, you would need to. These won't, because my a value is 1 every single time. So when I read that, I read it x minus 9 times x plus 3. Take the sign that is there. And again, notice I got the same factors that I got over here. All right, so that is factoring with the first term of 1, with that a value being a 1. Now, this one is going to appear to be slightly different, but in reality, it is not. Let's try. All right, and my directions are just factor. Now, I said it last example, and so let me say it again. Anytime your directions say factor, you always look for a greatest common factor first. And this is a great example of why. These do have a greatest common factor. It's 3. So first I'm going to factor out my 3 from all of the terms. All right, now we are not finished, because now we are going to factor the trinomial using what we just learned. All right, so this 3 that's sitting out front is going to stay there, and then we're going to multiply it by whatever the factors of x squared plus 4x minus 12 are. All right, so when I factor that trinomial, I'm looking for two things that multiply to b. Got to know what a, b, and c are. Now, I've already factored out that 3, so it is not a. A is 1, b is 4, and c is negative 12. So a times c is negative 12. And I'm looking for two things that add up to be my b value, 4. All right, so looking for two things that when I multiply them, I get negative 12. When I add them, I get 4. All right, so 6 and negative 2 will definitely do that for me. Now you can do grouping or faux fractions. Personally, like faux fractions the best. My a value is 1, put it over one number I found. My a value is 1, put it over the other number I found. So now I read x plus 6 times x minus 2. This is not our solution. Because remember, we had that 3 sitting out there. have to put that 3 in with our answer. Our factors are 3 times x plus 6 times x minus 2. If you don't have the 3, my math lab will count it wrong. Okay, you do have to have all the factors. And there's only one other kind of problem I want us to look at. Sometimes they're going to throw it out there where you have 2 variables, and that can get a little tricky. Okay, so there is not a greatest common factor. I do look for that first. There's not one. All right, and it is a trinomial, so I need to know what are A, B, and C. Now, when you look for A, B, and C, your A value is the coefficient in front of x squared, or whatever the leading squared term is. In this case, it is x squared. So my A is 1. All right. So notice, my variable here is x squared and x. Everything else is technically not the variable in my trinomial. So when I identify B, B is everything other than x. It's negative 4y. And C is 3y squared. That is slightly confusing. All right, so I'm looking for 2 numbers that when I multiply them, I get A times C. So 1 times 3y is 3y. And then 2 numbers that when I add them, I get negative 4y. All right? So the only way that will, this should have had a squared, I'm not sure where that went. The only way that's going to happen is if I have a negative 3y times a negative 1y. That way, when I add them, I will get negative 4y. When I multiply them, I will get positive 3y squared. All right. Again, you can go grouping or faux fractions. I will do it both ways this time, just so you can see both. All right, grouping. My first term comes down. My second term gets rewritten with the things that I just found with x. So minus 1y with x. And then my last term comes down. Right, so now I group. This first group has an x in common. And I would be left with x minus 3y. Okay, this is a negative, so I'm going to factor out negative, and they both have a y in common. I would be left with positive x minus 3y. Okay, now my groups both have an x minus 3y, so I factor that out, and I multiply by what would be left. So x minus 3y times x minus y. If I do my faux fractions, my A value is 1. It gets an x. It goes over one of the numbers I found. A value is 1. Goes over the other number I found. And then I read it. So x minus 3y times x minus y. Either way, we got the same answer. All right, so that is all for factoring a trinomial with A equal to 1.